Welcome to Math with Martin Frank. Today we're looking at a very basic concept of linear equations, finding slope. Slope describes the general direction of the line. If the slope is positive, the line will go uphill from left to right. If the slope is negative, the line will go downhill from left to right. If the slope is the ratio of the change in y to the change in x, rise over run. Also, if this fraction is improper, this ratio is improper, we have a steep slope. For example, 3/1 will be a steep slope. Hard to climb up, if you can picture climbing up with ropes. If this is a proper fraction, such as 1/3, we have a more gradual slope, something you might walk up. And of course, the slope of 1 is a 45-degree line with the x-axis. Let's look at an example here. We have the point 3, 6. 3, 6. Right here. And then we also have the point 1, 2. 1, 2. This point here. So we have a line that goes from 3, 6 to 1, 2. Okay, we're going to draw that line. Needed to get my ruler. Okay, so we have this line. And you see, if you look at what we just mentioned, this point, this is uphill from left to right. The slope is positive. It's also pretty steep. Can you imagine trying to walk up that? You couldn't do it. So this is going to be an improper fraction. Okay? We'll label the point here. This is the point 3, 6. And this here is the point 1, 2. And slope is rise over run. Now we can simply find slope by counting rise over run. Rise over run here, going from this point to this point, it goes up 1, 2, 3, 4 places. So the rise is 4. And then it goes over from this to here, or you could say up here and then over 1, 2. 2. So the slope is 4 over 2, which is 2. The slope of 2 over 1, which we just say is a slope of 2. Very steep and positive. It goes uphill from left to right and steeply. The slope is 2. Now the more formal definition of slope with the change in y and the change in x means that we're going to take the y values on top and subtract them. So we have 6 minus 2 here, the y values, the change in y. And the x values, if we start with this 6, we start with this 3, 3 minus 1. So 6 minus 2 is 4, 3 minus 1 is 2, and again we have 4 over 2, which is 2. Okay, let's look at another example. Okay? Now, when we get to more formal equations, we generally call slope m. No particular reason for that, it just evolved that way. Slope is m. The formal formula is change in y over change in x means y sub 2 minus y sub 1, x sub 2 minus over x sub 2 minus x sub 1, which is rise over run. And students get really worried about this at first. They say, well, this is a y and this is a y, which is sub 2? You know what? Doesn't matter. What does matter though is if I label, for example, if I label this as y sub 2, we'll call that y sub 2. That means that corresponding to that must be x sub 2. Now I didn't have to use this as sub 2, I could have used this as sub 2. But what matters is if this is y sub 2, then this is x sub 2. You can't just turn things around. Okay, now before we do the equation, we're going to put the line in and we're going to count the places and make sure we're correct. So we have the point 32, which is here. And then we have the point 54, which is up here. And so we have that line, the line that goes through those 2 points, connecting them. Okay? That line. Now if we just simply count, and this goes on forever this way, and this goes on forever this way. If we just simply count rise over run, we count up this distance from 2 to 4, 2, and run this distance 1, 2, 2. So 2 over 2, 1. The slope is 1. So we have a slope of 1. We know that. Now let's do the calculation. So you can do it both ways. The calculation, y sub 2 minus y sub 1. So m here is equal to, if we call this y sub 2, 4 minus 2. And x sub 2 will be here, 5 minus 3. So 4 minus 2 is 2, 5 minus 3 is 2, 2 over 2 is 1. M equals 1. That's a 45-degree angle with the x-axis. A 45-degree angle with the x-axis, a slope of 1. And it's positive because it goes uphill from left to right. Pretty simple stuff if you don't worry about it, if you just look at it and think about it. And practice a little bit. Everything takes practice. Some students get frustrated because they think they should know it right away and they don't practice enough. Okay, we're going to look at another example here. First of all, I want to put the line in and count so we see what we're doing. 3, 1. 3, 1 is here. And 1, negative 2. 1, negative 2 is down here. So this is the point 3, 1. And this is the point 1, negative 2. And so we have that line. Okay, let's look at that. It's a positive slope. We can see that right away. It looks like it's going to be steep. So it looks like we're going to have an improper fraction. Okay? So it looks like we have a steep line, looks like we have an improper fraction. And that looks like I got that off the graph. Okay. So let's put that down there again so you can see it. 3, 1 is here, 3, 1. And 1, negative 2 is down here, 1, negative 2. Okay, so now you can see it. And of course this line extends forever in both directions. So we'll put an arrow here and an arrow here. Now we want to count the slope. Okay, we're going to go rise over run. Well, let's see, up here this way, up here to there. So we have here from here 1, 2, 3 places. The rise is 3. And over 1, 2. The run is 2. Rise over run. Rise over run. 3 over 2. And we said 3 over 2. We said that we knew from looking at it, just from glancing at it, the slope is positive. It's uphill from left to right. And it's probably pretty steep. It's probably an improper fraction. So we have the improper fraction, 3 over 2. Okay? That's what we get. Now it doesn't matter what we call sub 1 or sub 2, as long as we're consistent. We started with this as being the sub 2's before. Let's do these as sub 2. This will be x sub 2. Just to show you it doesn't make any difference. Y sub 2, as long as you're consistent. Okay? So we're going to do the formula. So we're going to say y sub 2 minus y sub 1. Be careful. 1 minus whatever this is. And that is a negative 2. So it's 1 minus a negative 2. And then, if this was sub 2, this is sub 2. 3 minus 1. So 1 minus a negative 2, minus a negative is plus. So we have 1 plus 2 is 3. That's the rise. 3 minus 1 is 2. 2, that's the run. M is 3 over 2. The slope is 3 over 2. So I can look at that once I get familiar with this. I can say, somebody tells me the slope is 3 over 2. I know that it runs uphill from left to right. I know it's pretty steep. It's more than 45 degrees with the x-axis. Okay, we'll look at a couple others. Maybe 2 more. Bring this down a little bit now so we can see this. Okay, we have the point 5, 1, 5, 1. We have the point 4, 2, 4, 2. Put those real close together. So this is the point 5, 1. This is the point 4, 2. We've got a line between them. Let's put that in. That looks pretty easy. Okay, this time, notice the difference? This time the slope is negative. From left to right, it doesn't go uphill, it goes downhill from left to right. So we have a negative slope. Okay? Rise over run. Now, it doesn't matter which point we start with. They move in opposite directions. And that means that as y decreases, x increases. Or, if you want to go this way, as x decreases, y increases. They're inversely related, x and y, as they change. The change is inversely related. So here, if we're going from here to here, the rise is actually negative. It goes down 1. The rise is a negative 1. And we go over 1. 1. So we have rise over run, in this case negative 1 over positive 1 equals negative 1. The slope is negative 1. Okay, that's just looking at the graph. Now, doesn't matter what you want to call sub 1 or sub 2. We did these as sub 2 last time. Let's do this as sub 2 this time. Doesn't matter. X sub 2 and y sub 2. Okay, so we have m is equal to y on top. 2 minus 1. 2 minus 1. X on the bottom. Rise over run. X on the bottom. So we started with this y, we have to start with this x. 4 minus 5. Okay, so we have 2 minus 1 is 1. 4 minus 5 is negative 1. And we have a slope of negative 1. And this means we have a 45-degree line with the x-axis, but going downhill from left to right. Okay, we have one more example to look at. Okay, so here we have another situation where we're looking for rise over run. 4, negative 1. 4, negative 1 is down here. 4 and negative 1. And then we have negative 2, negative 1. Negative 2, negative 1. Negative 2, negative 1. So we have that point. Now, look at what that line looks like. This line is real interesting for our comparison of slope. And that's our line. And you should recognize that that's a horizontal line. Rise over run. rise over run. Well, no matter what point you go from and to, there is zero rise. And if we go, for example, from this point to this point, okay, the run, we have 2, 3, 4, 5, 6. It doesn't really matter though, because 0 divided by anything is 0. So this gives me a slope of 0. Rise over run. There is no rise, so the slope is 0. So when we do the equation, we should get the same thing. We'll call this x sub 2. We'll call this y sub 2. And so we have m is equal to -1 minus -1. And we started with this -1, doesn't really matter. 4 minus -2. So we have minus -1 is plus 1. -1 plus 1 is 0. So here we have 0 in the numerator. Minus the negative is plus 6. 0 over 6 is 0. And it doesn't matter where he's going from. You go from here, you still have a rise of 0. The slope is going to be 0 either way. Rise over run. Okay? Now, if you had, for example, a vertical line, because you probably want to know about that. If you had this vertical line, for example, didn't draw that very well. Let's assume that's a vertical line. Here there is no run. So if you have a vertical line, that would mean the denominator is 0. So what would the slope be if you had a vertical line? Vertical line. You have no run, you have a denominator of 0, the slope would be undefined. So with a horizontal line, you have a slope of 0 because there is no rise. With a vertical line, there is no run. With a vertical line, you have an undefined slope. And that gives you a general idea of slope. Slope does take some practice. All of this takes some practice, but it's very easy to accomplish with sufficient practice. So don't think you just have it. Go through and do some practice, get used to it, get comfortable with it, and you'll find out that it's not too bad, and it's very, very central to a lot of mathematical concepts after this. This has been Math with Martin Frank. I hope you've enjoyed it. I hope you've got something out of it here. Thanks. Bye. Good luck.